A warm welcome to all of you joining our webinar today. This webinar is about performance certification and how that can be a path to a more efficient and sustainable heating and cooling. My name is Anna Blomborg.
And my name is Morten Alm. The presentation we will give today will take roughly 25 minutes. Please keep all your microphones muted during the presentation. If you have any questions, post them in the chat box and we'll reach to the questions in the end of the session. I think that's basically it for the house rules.
Yeah.
Leave the floor to you, Anna.
And you'll get back? You come back?
I will get back. Thanks.
That's good. So let's roll the presentation. Today, the agenda is we will go through the sustainability challenge. We'll talk about the importance of performance and how to ensure efficiency. And of course, we will spend time on HRI performance certification. Now, for those of you who might not be so familiar with Alfa Laval, this is just a snapshot. We are a 4 billion euro company with close to 17,000 employees. We have 35 major production sites, and we are well represented with sales and service all over the world. You will always find an Alfa Laval sales contact close, and our service centers are always nearby. We regard sustainability both a necessity and a business opportunity. And we contribute to improved energy efficiency, heat recovery, better water treatment, and reduced emissions. And it's all about living up to our motto, advancing better. Decarbonization is one of the largest challenges of our time. But it's important to be aware that the challenge is a dual one. We must simultaneously support the rapidly growing energy demands while reducing CO2 emissions to meet the goals of the Paris Climate Agreement. By 2050, there will be a 54% increase in energy demand. And at the same time, we need to have a net zero emissions to be in line with the Paris Agreement and 1.5 degree global temperature increase. So how can we get there? Well, energy efficiency is actually one of the main contributors to reaching the Paris Agreement. And 50% of today's potential for energy savings comes from the industrial sector. But as much as 30% can be achieved in buildings. And the solutions to enable these energy efficiency improvements, they already exist. By the help of plate heat exchangers, we make it possible to save dramatic amounts of energy and thereby reduce carbon emissions. And energy efficiency doesn't only mean savings for the environment, but it also means financial savings for the operator. So if buildings have such a potential for energy savings, how can we capture this? Well, a good start is to make sure that equipment performs as intended. And maybe it sounds very simple, but the fact is that there is a lot of heating and cooling installations out there in the world that are underperforming. And there are different reasons behind this, but I'll go through the main ones. One reason can be that the initial design of the whole system does not deliver on efficiency. Or performance during operation have been degrading, maybe because it's not running as it is intended to, or maybe it has been lack of proper maintenance. And there are a lot of components out there that have been optimized on price rather than performance. And this is something that Morten now will dig deeper into. So welcome back.
Thank you. So, price versus performance. This is a thing that has been going on for a long time, and I think everybody feels the same thing. You want to buy something and you want to have good value for money. So you want something to be cheap, but still of high quality. The same goes for heat exchangers and heat exchanger equipment. We do see that customers are having, I would say, big issues to really get through this in a good way. They are struggling to really compare units in a good way, in a good process when it comes to quotation processes. So one of the main reasons, of course, is that heat transfer equipment is not an easy thing to evaluate. You get the specification from manufacturers, but it's really, really hard to really tell what unit will perform what. And it takes quite a lot of detailed knowledge about heat transfer to tell if the specification sheet at all is giving you the full picture and telling you the truth of the performance. So basically, I would say you could treat the spec sheet many times as just a piece of paper with numbers on it. It doesn't say much about the actual performance of the units that you plan to purchase. So when you're comparing two different suppliers, it might be a really, really tough target for you to get out of this in a good way. So just to clarify this, we made an example which we think will show this very, very well to you. So we are using this duty. It's a 4 megawatt cooling duty, very thermally demanding cooling duty with a narrow approach of 1 degree. So basically this means that the hot and the cold side of the heat exchanger will be only 1 degree apart. And this is really a demanding one. But we find this very often in the HVAC industry. Have a look at this duty. We will come back to it later on in the presentation. We will reuse it for the different examples that we use. So if we design two different units for this duty, on the left we have the AQ10TB, and to the right we have the AQ10TP. Both units have a DN250 port. So port size are the same, the height and the width of the unit, the distance between the ports, everything seems to be identical. But there is a crucial difference that influences the performance quite, I would say, gives a massive impact on the performance. You will not notice it at a quick glance, and you would not even see it in the specification text for these two units. So what is the difference? Let's have a look at the AQ10TB to the left first. For this specified duty, the unit would need a plate pack, which has a heat transfer area of 750 square meters to perform the duty. What about the other unit? Does it need more? Does it need less? It needs more. So the same unit that at a quick glance seemed to be very similar looking needs actually 3 times the heat transfer area in the plate pack. Although the technical specification doesn't mention what is the difference between the units. They look extremely similar on the paper. So what's the difference between the two units? It's quite clear in this case. There is a big difference, as you can see. So the truth here lies in the channel spacing. So the two units doesn't have the same channel spacing. The AQ10TB, which we have on the left side, has a channel spacing that is very optimized for this high demanding cooling duty. And for these type of duties, you will see that the performance increases with lower pressing depth or with a more narrow channel. And it's very clear. This gives a big impact. As you saw in this example, it's basically 3 times the surface needed. So if these two units were being offered to you in the quotation from two different manufacturers, and if they would claim it has the same surface and will do the same thing, you will not be able to tell which one is best just by looking at the specification sheet. So keep an eye out on this. It's really important to ensure that you get what you ask for, and it can be really, really tough to ensure that. So actually, we will continue again with the same example. We know from experience, we've been along for a really, really long time. In the HVAC industry and other industries, there is unfortunately a tendency, and it's very common, that heat exchangers are quoted with, on paper, inflated performance. So the performance figures that you read in the specification sheet are many times not true. As we saw in the previous example, it's really, really hard to tell what the real performance is. So this is a loophole, I would say, for many suppliers to create a quote that is competitive. So many times we see there is a deviation. So intentionally, the supplier would make a design that deviates and underperforms by half a degree on the temperatures. Sometimes less, sometimes more. But this is the tricky thing. This is what Anna refers to as being cost optimized. So basically, a supplier is making a quotation on a unit that is designed to produce a low cost rather than actually fulfilling the duty that you have specified. So if we look at the clear example, again, as said, it's the same duty. We had the as specified, sorry, one click back. As in the original specification, we've made a design that fulfills the duty exactly as it was written. We then need 100% plate surface, as we have here on the slide. If we then look at the price optimized design, we have this half a degree deviation. Remember, I also said that many times we could see 1 full degree deviation on the temperatures. But half a degree, we use that as an example. The impact of using half a degree deviation, as seen here, we get half a degree deviation on the hot side. We will not reach 7 degrees. We will go to 7.5. We will not reach 15 degrees. We will reach 14.5. The impact of this undersurface is basically that you can reduce the heat transfer area by as much as 30%. So half a degree deviation would give you 30% less heat transfer area, and of course then a much lower price. This is really a price optimized design. Okay, so if you get this design and you buy it, what will happen? If you put this unit into a building and into a building's cooling system, and it will underperform by half a degree or even more, most of the cases the building energy system or cooling system will be able to compensate for the underperformance of the heat exchanger. In a case like this, if we put it into the basement and connect it with a chiller plant, the flow rate on the cold media could be increased. So running the pumps with a higher flow speed, you would be able to compensate by the reduction for the underperformance of the heat exchanger. But when doing this, of course, the pump needs to work harder. And it's not only the pump that is working harder, it's also the thermodynamic that works differently in the heat exchanger. So you will lose out on the temperatures as well. So the pump will work harder. In this case, you see that the pressure drop in the heat exchanger will increase by 16%. But simultaneously, the temperature on the cold loop will not reach, not the 15 that was specified, not 14.5 that was let's say the cost optimized design. But when the unit is being run at full load, it will only get to 13.8 degrees. And when having this sub-optimization, you don't have the same temperature going back to the chillers or the cooling production, and that will also influence the efficiency of the total system. So we have the increased flow rates that builds up more pressure drop in the heat exchanger. In this particular case, we see 1/3 or 33% higher pressure drop in the heat exchanger, which of course drives more kilowatt hours for the pumps, which means more money spent on operating the pumps. At the same time, the overall system will work not as good as the return temperature back to the chillers will be influenced as well. So there's a lot of things that goes wrong. And it's not only the money, of course. When the pump is using more electricity, you also have a disadvantage or increased emissions on that side. So when you start to fool around with the performance, you will get hurt. The systems will not perform as intended. So that's the calculation example of the performance of the heat exchanger and the system and the impact. If we look to the next slide, we try to, again, we use the same example, and we will look into the to the performance and what kind of impact it gives on the financial side. So we use the calculation 4 megawatt cooling capacity, and the graph we will plot the investment cost and the added operational cost thanks to the negative impact of the undersurface heat exchanger. So as we see in this picture now, of course the initial cost of the price optimized heat exchanger will be lower, basically because it has less material in it, so it will be cheaper to manufacture, and it can be sold to the market at a low price. But when looking at when we add on the increased operational cost, we see that the break-even comes already after 1 year. So after 1 year, the undersurface heat exchanger has a lower investment cost, but after 1 year, the operational cost has increased so much that it's actually a negative price, or higher total cost. And if we look in this graph again, after 5 years, you will see that the total cost, so the investment cost plus the additional operational cost, is twice the cost of the correctly sized heat exchanger. If we extrapolate this to 20 years, which is 20 years life cycle is quite common in this type of applications, we will see that the additional cost, so the investment cost plus the additional operational cost, will be 6 times higher for the undersurface heat exchanger compared to the one that is actually sized according to the specifications. So that's quite a lot of money, and of course increased energy consumption. So that's quite a lot of details. Sorry for that, but it's needed to go through it. And I think we can conclude now that heat exchangers, they are sold at giving, let's say, less performance than what the supplier tells you in the specification sheets, and that will influence the system in one way or another, and it will always influence it in a bad way. So this is a question we get a lot of times, but it's really something you should look at, and that is that the heat exchanger, many times people say it's only underperforming when we operate it at full load, but that's only half of the truth. Of course, it will always have less surface, and it will always perform less good than the correctly sized unit. We also said that in most installations, it's possible for the energy system or the cooling system or heating system to compensate for lost performance or underperformance. But changing parameters will give a negative impact on the energy efficiency of the total plant. And we also conclude that it's more expensive to run the system when the heat exchangers are underperforming. So, and last but not least, of course, having a heat exchanger that doesn't perform will hurt your environmental impact. So if you want an efficient system, you have to ensure that the heat exchangers actually perform as intended. So I think this sounds really hard, I would say. Just looking at, there's a lot of details, and it might seem very hard to get the correct performance. But I think, Anna, I think you can save us here and give us a little bit further information about it.
I hope so too. Okay. So, listening to Morten talk about performance, and as he said, maybe you all think now that, this sounds very complicated. And yes, in some ways it is, but it can also be very simple. Either you will never be sure what you get, or you can decide to always be sure. And this is where HRI performance certification comes into the picture. And now I will talk about what that is. It might not be known to every one of you that there is a third-party certification program for plate heat exchangers available. Maybe you're used to buying chillers and cooling towers and other air conditioning equipment certified. Why not heat exchangers? So, HRI is a global certification program for liquid-to-liquid plate heat exchangers. It guarantees thermal performance and gives you the opportunity to compare quotes based on real performance. How does it work? All suppliers that want to join the program must go through a qualification process. HRI will randomly test a number of heat exchanger models from each supplier every year, and the lab tests will verify that design software ratings are within the program's tolerances on heat load and pressure drop. Failure to comply lead to re-rates of the performance, and when you've had a number of re-rates as a supplier, you will be excluded from the program. The HRI program has some limitations though when it comes to scope. It only covers water, seawater and glycols. The flow rates can be maximum 1260 liters per second, and maximum capacity is set at 70 megawatts. Now, looking at these limitations, I think you realize that in reality, they will not limit you at all. They are pretty wide. So, as long as the scope is met, there is always a reason for you to require and demand HRI performance certified heat exchangers. In North America, it's already mandatory in all HVAC applications. So why not specify it in data centers or tap water applications or general free cooling systems? They will all fall within the scope of the program, and they will all benefit from guaranteed energy efficiency. So hopefully now you're thinking, I want HRI, how do I get it? Well, this is super easy. You just add one single sentence in your specification. Heat exchangers shall be performance certified in the HRI liquid-to-liquid heat exchangers certification program. That's all. And when you see the HRI logotype on the quote and the documentation you get, you will know that you are getting what you have specified. And I think I'll invite Morten back again.
Thank you.
Let's change.
Thanks, Anna. So, the Alfa Laval history within HRI goes really back a long time. Changing slide as well. So, we've been member of the certification program, so the liquid-to-liquid heat exchanger certification program already since the start, which was in 2004. And of course, the reason it felt very natural for us to join, because we've seen the challenges, the way the market is behaving, and the negative impact of undersurfaced equipment and the underperformance we get. So we saw HRI, the certification program, as a really a good solution to get around this. And district cooling is actually one application where the HRI certified units are already widely used in at least some markets. And we've sold a lot of HRI certified heat exchangers to this industry. If we look at the calculations and the energy savings that we did before in this presentation, and we apply it to the installed base we have sold already to HRI, to the district cooling installation, actually, those heat exchangers alone in this industry would save 215,000 tons of CO2 emissions each year. That's quite a lot. And still, we're only talking about one industry from one supplier. Now, let's imagine that all heat exchangers used in the same industry, but on a global scale in all installations around the world. Actually, the energy savings would correspond to the annual production from 16,500 wind turbines. Again, this is equipment that is already available, sold on the market. The difference is that we will sell it with a guaranteed performance, and we will save a lot of energy. So, looking at these figures, I hope we all realize that HRI performance certification is a really nice way to enable or make sure and ensure that you reach the sustainability targets. and that we have efficient installations that are running in a good way. So the certification program is available. Just as Anna said, write it in the spec sheets that you want them certified and get on with it. So, last slide for me now. So, we are come to the end of the presentation, yes. Let's look at, just summarizing up what I think we've learned. I hope this is the key takeaways from this presentation. So, efficiency and sustainability goes hand in hand. The most efficient, or the most sustainable energy is of course the energy that never needs to be produced nor used. So efficiency is really, really key when it comes to reaching the sustainability targets. Efficient systems, they can only be enabled and really find the high efficient systems if all the components in the system operates and performs as designed and as intended. We have the HRI certification program for heat exchangers. That component, yes, we can guarantee the performance of the heat exchangers by only adding on the HRI certification. It's a perfect tool to ensure that that component is performing as intended. We saw also that the scope of the certification program doesn't limit you to specify it. Very seldomly we do get heat exchangers that are above 70 megawatt. Most of the cases we look upon in the HVAC industry and a lot of other industries are water-to-water, seawater or glycols involved. So there is basically no limitation. And then last but not least, of course, with the HRI certified heat exchangers, you get the tool on your fingertips to really validate, do I get the performance I want? And then you can compare the quotes on performance instead of guesswork. So ensure that you validate things based on the true performance. And of course that the equipment will deliver on the sustainability and efficiency measures. So Anna, I think it's the final slide even.
Yes, and we have finalized the presentation. I mean, we could talk about HRI for hours, literally. We are very passionate and feel very strongly that HRI is the way. But this is how far we could take you in 25 minutes. So I think we should open up for questions. I will see in the chat how it's looking. I think you are typing. Okay. So while we wait for you guys to type in your questions in the chat box, let's run some of the most common questions you and I get when we present this.
Yep.
So the first question would be, okay, what is the added cost for HRI performance? If I buy an HRI certified unit, what is the added cost for this?
Yeah, and I think the picture shows it even before I had the time to answer. But the actual cost for the certification program, if you look at it as a single cost on top of the heat exchanger sold, it is, I would say, not even marginal. It's 0.1% roughly. That is basically nothing. But I think we do get this question many times because people see that the heat exchanger will be more expensive when they are certified. But I think we should turn around the other way. If you're used to buy heat exchangers with a specific duty and then you get an HRI unit quoted and it's much more expensive, actually you did not buy the capacity that you thought you were historically. So basically the other unit was too cheap.
So the performance certification as such doesn't cost anything?
No.
No.
It just gives you certainty that you get what you asked for.
Okay. So second, very common question, can I get a quote from more than one supplier, or is it Alfa Laval only who offers this? Who are the available suppliers?
Yeah, this is, I would say, the second most common question, of course. And if you're in the market, I would say North America can be we can exclude North America because they've been living with HRI as mandatory for such a long time. But in new markets, we often get this question is, will I be limited by the number of suppliers? And as you see in this list over here, yes, there is 30 suppliers registered in the HRI certification program. So yes, you can choose among 30 suppliers if you want an HRI certified heat exchanger. And all the major brands, they are in the certification program.
So I can still get, you know, different quotes from different suppliers. I'm not limited as a customer.
Not at
all. Then we hear also, can I get heat exchangers, HRI certified heat exchangers outside US? What about origin of supply?
Yeah. Yeah, again, another question that is quite common, but there is no limitation. HRI, they certify the thermal design and the pressure drop of the heat exchanger. That's basically how the unit will perform. And if we assemble a unit here in the factory where we are today in Lund, or if we do it in Richmond in US, or if we do it in our factory in China or Russia, the heat exchanger will still be the same. So the performance is what is certified, not the assembly line.
Okay. Good. So no limitations either on the where in the world you can get it, right? Okay. So if I'm a customer and I have asked for HRI and I get some quotes, how can I verify that the quoted units comply with HRI? How can I know?
Yeah, I think the way I see it, at least, if it has the logotype and it follows, you know, if it is HRI certified, you will see, as Anna said, on the spec sheet, it's visible already there. But if you still feel that you are uncertain, you can always send the spec sheet to HRI to have it validated. Basically what happens is you go into HRI website, you download a form or you upload the spec sheet online. And what HRI is doing then basically is that they, when you send it to HRI, they have a copy of all the manufacturer's software to calculate. And then they make a recalculation of the same duty, and they will validate that, yes, what you have gotten quoted for this project is consistent with the performance that we have done in the manufacturer's software. And that's the same software that they use for doing this yearly testing design of units. So everything is validated by the actual testing, real-life testing. So it is, I think it's not needed for the validation, but it's still available.
So you're saying that HRI actually helps with verifying my quote?
Yes.
How much does it cost then? What's the cost of this service?
Zero.
Zero.
Yeah, no, it's as everything else. You know, you don't have to add any cost when it's HRI certified. Everything is paid by us as suppliers, and it's part of the membership fee into the certification program. So everything is covered, no cost for you.
Okay, so no cost either, then?
Only ups.
Why? Only ups. So these are some examples of the most common one. Let's see what you're writing in the chat. Okay. Someone is asking, the list we showed, is it just for gasketed plate heat exchangers?
Yes, so there are two certification programs for plate heat exchangers. The one we talk about today is for liquid-to-liquid heat exchangers, and that's the gasketed. So it's HRI LLHE. That's one certification program for gasketed. And then there is another, a sister of LLHE, which is called LLBF, which is then for liquid-to-liquid brazed and fusion bonded heat exchangers. That list is much shorter, but there is a different certification program for brazed heat exchangers.
So yes, the list we showed is for gasketed. Next question, what's the difference in physical product if you compare HRI certified heat exchanger and a non-certified heat exchanger? Is there a physical difference?
Okay.
Yeah.
No, should I or?
Yeah, no,
okay. So exactly, physically, well, if we look at the units we were using in our example today, we used the AQ10TB and AQ10TP. Those units are identical with T25B and T25P. So from a physical point of view, it's not different. But from HRI's perspective, you need to be able to differentiate the units. So the units designed in the HRI software from us and from all other suppliers needs to have a identification on the name. So it needs to have a different name, but it's the same plates, it's the same frames. Only thing is the name, and you put on the sticker. But the important thing is that the software that you use to calculate the heat exchanger is certified by HRI. You know that you get the performance.
Yeah, so it's thermally designed with an HRI tolerance.
Yeah.
But physically, it's the same unit, but it has a different name.
Yeah.
Okay, thanks. There's a question. Okay, we have heard that HRI certified only applies to HVAC applications. I think we touched that before, but let's do it again.
Exactly,
It's
I think
a
it was
typical misunderstanding.
It was
yes.
one of your slides,
Yeah.
Anna. So yes, no, it's in North America. It's mandatory in the HVAC industry, and it was intended from the beginning to be used in HVAC industry. But as Anna said, as long as you use water, seawater, or propylene or ethylene glycol, and it's within the scope, you can still specify HRI certified. So there's no limitation as such on applications.
Great questions. Keep them coming. There is one here saying there shouldn't be any difference in design when using HRI certification between competitors. And if yes, within which tolerances?
Yeah, I think that's a good question, and of course, this is a question which drives it to the end point, and this is really where the certification program makes a difference. If you have two units that performs differently, of course, it shows in the tests. So if you have a really good unit and a really lousy unit, they will not have the same surface and they will not have the same performance. And this really shows in the certified when you compare two certified designs. Whereas if it would be non-certified, you don't know the actual performance and they could on the paper look the same. So there are of course differences how good a heat exchanger is. So there will be differences. It's really hard to say it's unique for every type of duty, but for typically a cooling duty as the one we looked at today, there might be a surface difference of maybe 10, 20, 25% on surface from time to time if you compare two different units that has a good performance or a not so good performance.
But I mean, the main takeaway is that you as a customer shouldn't have to worry at all.
No.
I mean, the HRI program guarantees that the unit will perform. So you don't need to bother about surfaces and size and things like that. Good question. Okay, another question. Mechanical warranty for HRI certified heat exchanger is 3 years, question mark?
Yeah, no, again, this is, so HRI, they look only at the thermal and pressure drop performance. That is what HRI is all about. They test and validate that the performance and that the software is in line with the actual, that the design software is in line with the real performance of the units. When it comes to mechanical configuration and mechanical performance, that's outside of the HRI certification program. So it can be different between different, for us, I think even from different regions and different markets, and it's different from different suppliers. So that's totally disconnected from HRI certification.
So if you see 2-3 years and the difference, it's up to the sales company in that region to set and agree with you on a warranty. Wow. Another question, are the HRI certified heat exchangers limited to connections in inches rather than DN connections?
No, again. So everything that has to do with the frame and connections and stuff like that doesn't bother HRI. So HRI, they only validate and look at the performance, what they can measure in the laboratory. So the thermal performance and the pressure drop performance. That is what HRI is looking at. Then for different markets, of course, we have ASME pressure vessel codes, we have PED pressure vessel codes, we have different standards on pressure vessel codes, we have different standards on connections, etc. But in our world, our units are called, if you have a T10, it will be a AQ4 because it's the inch size. But it has nothing to do with what HRI says in their programs.
Now we can say that our complete portfolio of gasketed plate heat exchangers, they have an HRI equivalent. So from the smallest plate heat exchanger to the very, very big one, you can always get it HRI certified. The whole range is covered. Now, if you feel that, I have questions or this was a lot of information, we will post a version, this webinar as a download, so you can listen into it one more time and really dwell on what we've gone through. Otherwise, if you want to know more, I encourage you to go into alfalaval.com and read about our sustainable solutions. And you can follow us on LinkedIn, connect with me and Morten, and start the conversation with us that way, right?
Yeah, either with us or, of course, with Alfa Laval sales in your region.
Yeah.
Yep.
That's good. So with this, I would say thank you, of course, for your attention and your time. We really hope that you found this webinar useful. Anything else?
I think I don't have anything to add right now. But as said, if you feel that you need more information about this, search for your local Alfa Laval sales people or don't hesitate to contact either Anna or myself.
So, other than that, we'll just say goodbye.
Bye.